This is the first episode in a 3-video series on Git for beginners. If you know nothing about Git, then you are in the right place. I will be releasing all 3 videos at the same time, so if you reach the end of this one, you can continue watching. I will be using the git command in a terminal and in parallel the git client included in Visual Studio Code. If you are using Windows and you want to follow along with the terminal commands, you will need to use git bash included in Git for Windows. In this first episode, we will use Git locally in a single branch. We will initialize the repository, create a few commits, then look through the commit history, see how we can revert to a previous version. We're also going to look into gitignore and also git stashes. In the second episode, we will continue to work locally, but we will start using multiple branches. And in the third episode, we will start using remote repositories, and we'll also see how we can work with GitHub. With that being said, let's get started. I'm going to take some notes in this notes markdown file, which I will make available in a video description below. And we're going to start by discussing what is Git. And the answer is that it's a distributed version control system. Now, what does version control mean? So let's imagine that we have a file, let's call it file 1. And it doesn't matter what the contents of these files are as long as it's text-based. So it's very important. Git only works with a text-based file, not binary files. So Git only works with text-based files. And now text-based means that they can be computer programs in whatever, Java, Python, etc., or they can be markup languages, let's say HTML, LaTeX for scientific writing, it can be CSS, etc., or it can even be a text file. Let's say you are writing your journal in a text file and you want to track it by Git. Now let's imagine that the file in this moment is in a good state. It's a computer program that is working very well, and you want to start working on a new feature that might break the existing version. So what you might be tempted to do is make a copy of this file. Let's duplicate it, and then we can name it something like file1.bk for backup. And we start working on this file, and if things don't go well, we restore from this version. And then we can also have multiple versions of it. Let's say we save checkpoints along the way, so we would duplicate it again. And this one will be, let's say, backup number 2, and so on. Or you can even name them something like V1, V2, etc. But the problem with this approach is that it will quickly get out of hand, especially if we have multiple files that have different parallel versions. Some approaches, we can make archives of our project and save them in a directory, but this pretty much is what this is version control, which means having multiple versions of your project and then being able to go back in time and restore previous stable versions. Now we're going to discuss about the distributed aspect of Git. And what it means is that there are multiple copies of your project, some of them hosted on the internet, or they can be hosted on your local network, and potentially they will be operated by other people, by your colleagues. And I made a diagram to illustrate this. So let's say you have your copy locally on your local machine, and then there is this master copy of the project instance hosted on GitHub, but it can be any other service or no service at all, just the server on the internet. And then there's one of your colleagues that also has another instance of this project. And at this moment, you all are using the V3 project. Let's say the project has one file and you all have the third version of this file. Now you make a change to this file which will make it V4, and then what you will do, you will push your changes to the master copy on GitHub. So now the master copy is running on V4, and then your colleague will also pull the changes from the master copy, and then he will also be on v4. And etc. If he tries to make a change, increase it to v5, he makes the change locally, then he pushes this change remote to the remote server, and then you pull it from the remote server. Even if you work by yourself, it's still a good idea to have a remote copy of your repositories somewhere on the internet, for example on GitHub. So if you have a project and you don't want to share the source code publicly, then you can create a private repository, and in this case you use GitHub as a backup. So for example, if you lose all the data on your local computer, then you can restore it from your GitHub account. And but also you might want to share the code publicly, for example, if you're building a portfolio or you're trying to start a new open source project. With that being said, we can now start using the Git software. You will notice that I will use generic files in this video, like file 1, file 2, and I will add generic modifications, like I will write line 1, line 2 in these files just to illustrate the concepts. You need to understand that to Git, it is not important the type of file or the programming language it is written in. It treats all the text files just the same. And if you want to follow along, feel free to use files written in your programming language. I decided against using one because if some viewers are not familiar to that language, I don't want them to be confused. If your computer is a Mac or Linux, you should already have Git installed. And if you are using Windows, then you need to go to the Git website and install Git for Windows. And if you want to follow along with the terminal commands, you will need to use git bash, also included in Git for Windows. So I'm gonna close this diagram for now and also delete these two copy files that we made earlier and open a terminal window in the current directory. The first thing that we need to do is initialize a repository in the current directory. You can think of a repository just like a Git project that can have multiple files. And if we go to Visual Studio Code, so there is this tab in here called Source Control. That is the icon. It's like some sort of a upside down tree. And in here it says the folder currently doesn't have a Git repository. We can initialize it, or we can initialize it from GitHub, but we're just going to do a simple initializing right now, but we're going to do it from the console. If you click that button, that will do it. And the command that we will use throughout these tutorials is the git command. So if we just type git help, it will show us all the commands available. And the one that we're going to use is this one, git init. And if you want to learn more about one command, you will type in git help and then that command, git help init, and it tells you how to use it, what options you have. But for now, we're just going to do git init and the current directory. Make sure you are in the same directory as the Visual Studio Code project. So my directory is git1, and this one in here is also git1. So we type that one, git init, and it says right here, initialized empty Git repository in our directory. One thing to note in here is that if we look in all the files in this directory, we will see that there is this .git directory that if we just list it, it won't show up because it starts with a dot. And that directory contains all the internal data relevant to our repository. So all the objects. So if you delete that directory, the .git directory, all the history of your files locally will be lost, and it will be just like we never ran git init and we don't have a repository in the current directory. The next command that we are going to discuss is git status. And what this command does is that it prints the status of our repository. And it says right here that we are on branch master. We will stay on this branch in this video. We're going to use different branches in the second video. It says right here we don't have any commits. So you can think of a commit as a version to your file. And it says right here that we have a bunch of untracked files. So for a Git repository to keep track to the changes to a file, we need to add it first to the repository. So you can think of it like whitelisting the file in the repository. And if we go to Visual Studio Code, to this source control tab, we will see here that the view is very similar to Git status. It shows us so the U right here, it means untracked, and it will say right there untracked. For adding files to our repository, we will use the git add command. So we just type in git add and the name of the file that we are trying to add. And now if we do git status, we would see that our file just got moved to this separate section called changes to be committed. So, and if we go to Visual Studio Code, it moved into this area called staged changes. So the way this works is that we work on some files, or we add files for the first time, and then we stage them into this area, and then we create a version with all the files that we modified. And if we want to continue working on our file, we can unstage it by using this command right here. We can try it out right now. And file 1. So now if we do git status, it says untracked again. And in Git source control, we can stage files by using this plus sign in here, and we unstage them using the minus. And one thing to note is that we can have multiple files staged at the same time. So if we have a second file in here, and they don't have to be empty, they can have already some contents. So we're going to save this one. We go back to source control, and now we add the second file, and now they are both staged. Once we staged a bunch of files, we can create a commit. And you can think about this as introducing a new version to your project. And each of these commits can contain changes to one or multiple files. If this is the first time that you create a commit on your local computer, then you will need to configure your user information. So we go to the terminal and we type in git config, and there are two properties that we need to set. The first one will be our username. So you can put in your first and last name. And so this change will only apply to the current repository. If you want to make it apply to all the repositories on your computer, you need to add the -- global flag before user.name. And the second property that we need to set is user.email. And here you can put in your email. So you don't have to put in correct information in here if you don't want. This will just help identify when multiple people work on a repository. We want to know which person made which change. Once we set these two properties, we can continue by creating the commit. And the command in the terminal will be git commit. And for each commit we make, we need to add a short description of the change that we are making. And we set this message with -m, like the commit message. And in here, we can type in something like adding file 1 and file 2. And then we close the quotes. And if we hit enter, this will actually create the commit or the change. And in Visual Studio Code, this is equivalent to adding a message here. Let's say adding file 1 and file 2. So if we click this button or we hit enter in here and execute the command in the terminal, the effect is the same. And we see here that it says master, this is the branch we are in, this is the commit that was just created, this is the message we typed, and this is what actually happened. It created two nodes, two two files in our Git repository, and this is the file permissions. Now let's see what happens if we run git status again in our repository. So we will notice that file 1 and file 2 that we just committed to our repository are no longer listed in git status. And this is because they are considered clean, meaning that there is no difference between the version that is on disk and the version that Git knows about, so the latest version that is committed into our Git branch. However, if we make a change to one of these files, let's say we need to go back to Visual Studio in the Explorer tab, and let's say we add another line in file 2. So second line, we save the file, and now if we go back and we run another git status, it will say that the file 2 is modified. So notice how it's not considered untracked, but instead is modified. So modified files are files that were already added to the repository, but now they have local changes that makes the file different than the one Git knows about. If we want to save modified files into our Git repository, we follow the same workflow as for adding untracked files. So we need to add them first. We will do git add file 2. And now if we do a git status, this file will be moved into it will be staged for commit. And now we create a commit just like before. But this time I want to show what happens when we don't set the -m argument to git commit. So what will happen is that Git will open the default editor that you have configured with Git. In our case, it will be Vim. So I think in Vim, in case you're not familiar, you type I and then you type the commit message. So the commit message will be added second line to file 2. The advantage of opening the editor is that you can write a lot more than just a few characters, like a sentence in an inline message. So if you're working on a complex algorithm or something that needs more explanation, you can open this editor, and once you're done, you hit escape, colon, and WQ. That's the Vim editor. The way in which Git determines which editor to open is through a config property named core editor. And we can change this property to our preferred editor just like we did for username and email. So the command will be git config and then the property name core editor. And the command that launches Visual Studio Code is code. You need to do some additional steps after you install Visual Studio Code in case you don't have this code command in the terminal. And then we need to add two flags, -n for opening Visual Studio Code in a new window, and also -w because Git will have to wait for this command to finish. So now we can try it out, and let's say we make a change to, we add a line to the file that was empty to file 1. Let's say F1L1. And now if we do git status, we will see that the file is modified. We add it just like we did before. And now if we do another status, it will say right here that it's modified. So now if we type git commit without a -m, it should open Visual Studio Code. And it opened it in a new window, and we can type in here our message. So let's say edit the first line to file 1. We need to save it, and now we close this window. And we see that it created a new commit with our message. Now that we made some changes to our repository and created a few commits, you might ask yourself, how does this help us? How can we interact with this repository? And we're going to start by looking into the git log command. And what this command does is that it prints a history of all the commits in our repository. We can, in our case, we have only 3 commits. This is the first one where we added the 2 files. This is the second commit where we added the second line to a file, and we added the first line to file 1. And we can see here the author of each commit, which is myself in all 3 commits, and it used the properties that we said in the beginning, the username and user email. We see the date here, and also each commit has this unique identifier version number. So this will be the first one, the second one, the third one. It's not using v1, v2, v3 because the Git model is a tree, is not a linear model. And it can have multiple timelines in parallel, so it wouldn't make sense to have the versions incremented have a counter number. And also, in some instances, these commits can be merged together or reordered, so it will be hard to keep a consistent number 1, 2, 3, 4. We can also use git log to see the history of a particular file. So if we do git log, then -- and a file name, let's say file 1, we will see that the second commit is missing because the second commit in here only applied to, we only made a change to file 2. And also in here, if we see the history of file 2, we will see that the third commit is missing because in that one we only modified file 1. We can take a look at the changes included in one particular commit by using the git show command. And it takes as argument one commit version. We are going to use this commit where we added a second line to file 2. And we don't need to paste the entire commit number if we don't have it. Usually just it needs to be a prefix that is unique in our Git history. So if you use 5, 6 characters, that should be enough. You'll see that GitHub, it only prints a few characters when they show commit numbers sometimes. If we look at the output of this command, we see the same information like in Git history. So the commit number, author, date, and our commit message. But we also see the changes that we made to the files. So in here, it says that we made a change to file 2, and A will be the old version, B is the new version. So in here, it says that we deleted this line that said contents, and we added 2 new lines, one that said contents and one that is saying second line. And this is a bit confusing because this line that said contents is the same as this one, but what we're not seeing in here is that in this line right here in the new version, it has a new line, character /n at the end in order for us to go to the next line. And to Git, even if you add a white space character that is not visible in here, if you add a white space character to a line, then Git considers that you modified it. With git show, we can also see the contents of a file at a previous version in our history. So, for example, if we want to see the contents of file 2 when we first added it, we take this first commit that says adding file 1 and 2. So we do a git show, then we take this commit version from here, a prefix of it, and then we type in colon and the name of the file, in our case file 2. So it will show us that at that at that version, it only had this string contents in there. And if we try it with the newer version, when we added the second line, so we paste this commit version from here, and we will see that it has both lines. So this is a pretty safe way to revert a file. If you have a single file that you're trying to revert or just a couple of files, then this is a very safe way of doing it. You either, let's say you copy the contents from here from the console and you paste them in Visual Studio Code, or you can even do a pipe in the terminal, so with greater than sign file2, and this will override it to the previous version. We will see later how to revert the entire project back to a specific version, but usually there's some risk involved. You can mess that up. If you only have one or two files, a couple of files, I recommend doing it this way. Now let's see how we can look at the Git history inside Visual Studio Code. So if we are in the Explorer tab, at the bottom there should be one section called timeline. So this one works if we have one file selected. Also, if you are missing that timeline section, it might be from these three dots in here. So make sure you have timeline checked. And once we select one file, we open the timeline, but we see that there are some Git events in here, but also some local events, and we can filter out the local events. So now we have all the commit history of that file. And if we click on one of these commits, we will see the difference, like the changes that were included in this commit. And of course, if we switch to the other file, we will see that the history changes and it shows us the history of that file. There are, however, some big problems with this timeline feature in Visual Studio Code. One is that it can only show us the history when we have one file selected, so we cannot see the history of the entire project or of a specific directory. And the second one is that it only shows the difference included in a commit and not the entire file, so it's missing a git show feature. You might think that you can copy this contents in here, but if our file had 100,000 lines and we only changed one line, then this view would only show a small section of the file, and we cannot restore it to the previous version with this method. There are several extensions that have this missing functionality. One that I like is called GitLens. So if we go to Extensions tab in Visual Studio Code, and we search for GitLens, L-E-N-S, and it's this one over here. You will need to install it, then enable it. If we go back to the Source Control tab, we will see that there are some new sections that were added at the bottom. The first one says commits and is the Git history of our entire repository. If we click on one of the commits, actually if we expand it, we will see there are all the individual files and the changes that we made in that commit. So if we click on one file, we will see the change that was made in that file. And also there is this tiny button in here that says open file at revision, which is equivalent to a git show at this commit version. So this one will show the entire file. And also in here there's a different view of this commit history with this fancy graph. And another feature is that if we have one file selected in the editor and then we go to file history, we will see the Git history specific to that file, just like in the timeline view we saw earlier. And again, it shows the differences included in that commit. But also we have that button for a git show. Now I would like to circle back to the git add command and see some additional features that we can use. Let's say we make a change to one of our files. For example, we add a new line to file 2 and we save this file. And now the question is, if we do a git status, it will say that file 2 was modified, but the question now is what is actually modified? So what is different than the version that was last committed? And we have a command for that. It is called git diff, and then it takes the name of the file, file 2. And now we see the differences in the diff format. So we have A/file2, which is the Git version, and B/file2, which is our version that we modified. These are the old contents. We will see here second line without a new line, and the new contents, the things that we changed is that we added a new line to second line, and we also added an additional line. In Visual Studio Code, we can see these differences by going to the Source Control tab, and clicking on one file that was modified, we see the local changes here. And let's say we are not happy with our local changes and we want to revert back to the version that was last committed in Git. We can do this by typing in this command that git status mentions in here. So git restore, and then the file name, file2. And now if we type again git status, we will see that file2 is no longer modified. If we have multiple files modified locally, it would be annoying to stage them one by one using git add. Thankfully, git add and other git commands can take as argument a directory name and also file names with wildcards in them, with asterisks. Let's see an example of this. So if we go to File Explorer, we will add the one new line to both file1 and file2. Let's say ABC, save the file. We go to file2. DEF, we save the file. And if we go to the terminal and type in git status, we will see that both file1 and file2 were modified. As we discussed earlier, git add can take as argument a directory name, and that includes the current directory. So if we type in git add and dot or the current directory, this will stage all these four files, file1, file2, and also the two untracked files .dstore and notesmd. And if we type in status again, we will see that all these 4 files are staged. And git restore also takes directory name. So if we type in git restore -- staged and then current directory or dot, this will unstage all the 4 files. And also git add takes wildcards as arguments. So if we do git add and then file and asterisk, this will add file1 and file2. And also git restore works as well. So file asterisks. And now if we do git status, we will see that they were unstaged. Git add dot is a quick way of staging multiple files at a time. However, in many instances, it is too generic and it will include files that we don't want to add to our repository. Some common examples are binary files in compiled languages or configuration files that contain sensitive information like passwords or API keys. We can address this problem by implementing a blacklist of files that we never want to add to our repository. Let's say that we never want to add these notesmd file and the .dstore file. And the way Git implements this is by a special file called .gitignore. So if we go to Visual Studio Code in Explorer and we add a new file, the name of the file needs to be dot and then gitignore. And in here, we can type in the name of the files that we want Git to always ignore in Git status. So in our case, it can be notes.md. And we will see that now if we type in Git status again, notesmd is no longer listed as untracked. Visual Studio Code also implements the gitignore feature. And if we go to the source control tab and we right click on a file, let's say on .dstore, we will see that we have the action of add to .gitignore, and if we click on it, what it will do, it will just add a new line to the gitignore files with the name of the file we just added. And also now we will see that it is no longer showing up as untracked in the changes section. Just like git add and restore, the gitignore files also support wildcards or asterisks and directory names. So instead of notes.md, we can use asterisk.md, and this will ignore all the markdown files. This is useful for binary file formats. Let's say if we work in Java, we would want to add .class to the gitignore files. And also it supports directories. Let's say all our binary files are compiled into the bin directory, then we can just do something like this. If you are working on a specific language or framework, you can search the internet. There will be generic gitignore files specific to your platform. And lastly, about gitignore, I would like to discuss if we should add this file to our repository or not. There is not a hard rule. You can decide to add it or not add it. In general, I add my gitignore files to my repository because if a new person pulls my code, let's say from GitHub, maybe they will have an easier time setting up their development environment. And if you decide not to add it, then you can ignore this file. So you can add .gitignore to the gitignore file, and we will see that it disappeared from the untracked files. However, in our case, we will add it to our repository, and we will create a commit from it, this time from Visual Studio Code, to practice committing code from this UI as well. So we just click on this plus sign, and now gitignore is in the staged area, and we are going to type our commit message. Let's say add the gitignore file, and click commit, and now we are good to go. Next, I would like to show a command that will help us better understand the history of a file line by line. And this command is called git blame, and it takes as argument the name of the file. Let's say file2, and we see in here to this right side the lines that we have in our file. So we have contents, second line, and DEF, and this is the line number that was added by this command. And on the first column, we will see the commit number where that specific line was last modified. We see in here this previous commit where we added, and this one it says not committed yet because it's these are some changes we make locally and not committed yet. So let's go ahead and commit these changes. We stage file2. Let's say add a third line to file2 and hit commit. And now if we do a git blame again on file2, we will see that the first line was, so the first line content was last modified in this commit number, and the second and third lines were modified in this commit number. And once we have the commit numbers, we can do a git show on them. So if we do a git show on this commit, we will see that we modified that line where in the commit where we added the second line to the file. And if we do a git show on this other commit number, we will see the commit that we just made. How is this useful, you might ask? Well, if you are investigating a bug in your program and you find the line that caused it, then you can do a git blame, and you see that Bob last modified that line, and now you can blame the bug on Bob. Well, just kidding, but yeah, if you find the line and you see the commit number, you can do a git show on that commit, and you can better understand the context and what that commit was trying to address, and maybe it's easier to correct the issue. Now let's see the Visual Studio Code equivalent of git blame. So if we open file2, we go to Explorer, and in here, and we will see that when we are on a line, there is this grade text in here that says when that line was last modified. It says myself 11 minutes ago. And if we hover over, it will show us the commit number. Of course, if we switch to another line, this grayed out text will update. And this can work. You can keep this toggle. I think this is enabled by default from GitLens, I think, but if we want to see the same view as the git blame command in the console, there's this button here in the upper right corner from GitLens, and we can toggle file blame. And we will see the same view. So the first line was modified by this commit, and then the second and third line by the commit we just made. Next, I would like to discuss how we can revert our entire repository to a previous version. If you search on the internet and on Stack Overflow, you will see that many people recommend using git reset. However, if you are a beginner, I strongly recommend that you don't use git reset because you can easily get yourself in trouble. If you do want to try out these methods, then please make a backup copy of your repository. So just copy the entire directory in a different place, and then if you mess up one copy, then you can continue using the other one. Instead of git reset, I recommend using git revert. And the main difference to this command is that it does not erase commits, but instead it creates new ones. What do I mean by this? So let's say we have commit 1, commit 2, commit 3, and we want to go back to commit 1, then while git reset might erase these commits 2 and 3, what git revert will do is it will create a new commit, commit 4, that just changes the files affected to the version in commit 1. In my opinion, this makes git revert much safer to use because there is no risk of losing commits unnecessarily. Now let's see how we can use the git revert command. So let's take a look at our history first with git log. We see the latest commit we did is this one, DC34. And just so you know, the latest commit in the history can also be referred with head. This is an alias provided by Git. So if we do git show head, we will see that in this last commit, we added the line DEF to line 2. So we can revert this change by doing git revert and the name of the commit, which again can be DC34, that one, or we can just refer it to it as head. And this will automatically, git revert will automatically add a commit that reverts this change. But if we want to take a look first at the changes that will be reverted, we can use the flag --no and then commit. Or also this flag has a short value like just -n. So if we run this command and we do a git status, here Git tells us what options we have. It said that it staged the file 2 with the changes it reverted. And we can take a look at these changes by doing git diff --staged. And then the name of the file. And we see that it removed the line DEF, which is the change in the last commit. We added it and the git revert removed it, which is what we expected. So if we are happy with these changes, we can do git revert --continue, and this will open the editor that we have configured, and we can type in the commit message for the revert commit. We can also do git commit -m, and with our message, let's say revert the last commit. But in our case, we will just abort this revert process. So we'll do --abort. Git revert also works with ranges of commits. And for this, I would like to make a change to file 1 as well, and then try to revert both changes to file 1 and file 2. So let's see what changes we have locally in file 1. We added this new line called ABC, and this is good. So we can stage it, file 1, git status, and now we commit. Let's say add line add ABC to file 1. We added a new commit. And now if we do git log, we will see that the last commit is add ABC to file 1, and then the second one is add a third line to file 2. Now we can revert both of these commits by providing an interval of commits as an argument to git revert. So how we use it is git revert. We use the -n flag again because we want to see the changes that were reverted before we create the commit. And now the way it works is that we specify an interval. So let's say this commit and then ... and then the last commit in the interval. So this one. However, the interval operator in Git is inclusive to the right and exclusive to the left, which means that at the left side, we need to actually specify the previous commit to the one that we want to include in a revert. And in our case, it will be this one over here. And there are some, Git has some aliases as we saw before. So the last commit will be head. And also there is an operator that given a commit, it will return us the commit before. And this is useful because we can provide in here at the left side the commit that we actually want to include. And then by typing in this character, this moves this commit to the previous one. And so we can try out this command. And now if we do a git status, we will see that both file1 and file2 were reverted. And if we do a git diff, let's see, staged, and we can do current directory, and because we want to see all the changes, we will see that in file1, the ABC line was removed, and in file2, the DEF line was removed, and this is good. And now we can try the git revert -- continue, and we will see that it opens our editor, which is Visual Studio Code, and it already populates this the commit message to revert these files. Let's say revert, yeah, it is incomplete. Let's say revert last 2 line adds to file1 and file2. And we save this with Control S or Command S. We close it. And now a new commit was added. So if we do a git log, we will see that this revert commit was just added. And if we do a git show head, we will see the revert we just did. We removed line ABC to file1 and DEF to file2. So far, we only added files to our repository, but what happens when we need to make other file operations like copies, removing files, or renaming them? Well, thankfully, Git has subcommands for this. So if we do a git help, we will see that in here we have git mv for moving or renaming a file, and git rm for removing files from our repository. There is no git command for copying files, but we actually don't need it. So let's say we copy file2 into file3, and now if we do a git status, we will see that it identified file3 as a new file. So now we can add it, file3, and add a new commit for it. Let's say make a copy of file2 into file3. If we list the files in the current directory, so if we do an ls, we see that we have file1, file2, file3. And if we take a look at the contents in file3, we will see that they are the same as in file2. However, if we do a git log on file3, we will see that we only have the last commit where we added this file. And of course, if we do a git log on file2, we have the entire history. So when we copy files this way, they don't transfer the git history of the files. If we want to delete this file from the disk and from our repository, we can use git rm file3. And if we do a git status, we will see that this file was staged as deleted. And if we look into our local directory, we see that it was also deleted from the local directory. If we change our mind and we want to restore this file and not commit the deletion, we can use the command git restore -- staged mentioned in here by git status. So file3. And if we do a git status again, we need to do another restore, git restore file3 again. And now if we look in our local directory, we see that the file is back. Visual Studio Code, if we go to the Explorer and delete one file, so just right click on it and then click delete and move to trash. And in source control, the file was staged as deleted, and now we can just add a commit message and let's say delete file3. Moving or renaming files is similar. We go to the Explorer and let's say we want to rename this file2. Right click, rename, let's call it file4. And if we go to changes, it said that we removed file 2 and we added a new file, file 4, with the same contents. But for now, I'm just going to revert it from here. So we need to unstage both changes because I want to see it in the console as well. So if we do a git status and we list our current directory, we see we have file 1 and file 2. And we are going to use the command git env file 2 to file 4. File 2 is the old name, file 4 is the new name. Now if we do a git status, we will see that it was file 2 was renamed to file 4. So now we can commit this change, this stash change. We say rename file 2 to file 4. So now if we do a git status, so we'll see that the status is clean. And if we list our current directory, we see that now we have file 1 and file 4. And if we do a git log on file 4, we will see that we only have the last commit, the one that renamed the file 2 into file 4. So one thing to keep in mind when we move files or rename them, the git history of that file will be lost. The last concept I would like to introduce in this episode is that of git stashes. Git stashes are a way of saving work in progress changes without introducing a new commit to the repository. Imagine you are in the middle of working on a new feature, and let's say currently your project is not in a good state. Maybe it doesn't compile or it doesn't run as it should. Out of a sudden, one of your users reports a production issue that needs to be investigated immediately. So what you want to do is interrupt your current progress, revert your project back to the latest stable state or the version in the last Git commit, and then work on the production issue. Once the crisis is averted, you will want to resume working on the new feature from where you left off. But now the question is if there is a way of stashing away these work in progress changes without introducing a new commit. The answer that Git has for this problem is the git stash subcommand. Now let's see this command in action. So our current working tree is clean. If we do a git status, it will say right here, it means we have no local changes. So we'll go ahead and make a change to one of the files. Let's say in file 1, we add a new line XYZ and we hit enter at the end. Now if we do a git status, it will say file 1 is modified, and if we do a git diff, we will see the line we just added. And now how do we save this local change without introducing a new commit? So first let's take a look at our Git history. So the most recent commit is the one that says rename file 2 to file 4. And again, we have one file that was modified. So now if we type in git stash, this will revert file 1 back to the version we last committed to Git. And also if we look at our history, it didn't introduce a new commit. The most recent commit is also the one that says rename file 2 to file 4. Now the question is, where are these changes saved? So if we do a git stash list, it will show us all the stashes we have. And if we do a git stash show and then -p, it will show us the actual changes that are included in the latest stash. And also we can have multiple stashes at a time. Let's make another one. So also in file 1, we're gonna add a second line again, 1, 2, 3. And if we do git stash again and git stash list, we will see that now we have stash at 0 and stash at 1. And if we do a git stash show p, we will see that actually the latest stash right now is the one where we added 1, 2, 3. So this list works as a stack, and the most recent stashes will be at the top. So if we want to see the changes included in the previous stash, we can do git stash show p, and then this other stash version stash at 1. And in here we will see that is the first stash we created, the one with the XYZ line. Now, how do we resume some of these changes we stashed away? And there are two commands here we can use. There's git stash pop and git stash apply. So git stash pop will apply the stash at the top of the stack and then at the same time remove that element from the stack. And git stash apply tries to apply that change but without removing the element. Between these two options, I prefer to doing git stash apply, and then if the application is successful, I can do git stash drop afterwards to actually remove that change if I want to. If you want to see all the git stash subcommands, you can do git stash help. So here we will see git stash pop and apply for applying changes, drop, show the one we just used, and list as well. And also if you want to clear all your stashes, if you think those are old changes you no longer need, you can use git stash clear, and that removes all the elements from the git stash stack. Now we can try applying our stashes to our local code. So if we go to file 1, we will see that it reverted back to the version that was last committed that only has one line. And now if we do a git stash apply, we will see that git stash added this 1, 2, 3 line, which was in the stash at the top of the stack. And the file is not staged for commit. And if we do a git stash list, we see that stash at 0 is still there. So let's do a git stash show. Like that. Actually, we need to add the -p. So this is the stash we just applied, and because we applied it and we have it in our local branch, we can now do a git stash drop, and that removed that stash from the top. And now if we do a git stash list again, we will see that we have the old one right now. So if we do a git stash show -p, we see that we have the XYZ stash that we added first. One thing to note is that in order to apply stashes, our working tree needs to be clean, so we cannot have any local changes. Actually, let's try git stash apply again. And we will get this error message: your local changes to the following files must be overwritten. Please commit, stash them, or we can revert back to the Git version. So yeah, we have this file 1 that was modified by stash, and I will commit it for now. Let's do git add file 1 and git commit, and I think we add line 1, 2, 3 to file 1 as a commit message. In some cases, stash application can also fail. So if we do a git stash show again to see the stash on top of the stack, we see that this stash is trying to add a string XYZ as the second line in our file 1. However, if we go to file 1, file 1 already has a second line, and the contents of this second line are 1, 2, 3, which is different than what is in the stash on line 2. So if we try to apply git, let's do git stash apply, we will see that it fails and we get this conflict message from Git. Now, you will get merge conflicts and other commands, not necessarily stashes. We will see in future videos. And what Git does is that it modifies our file and it adds both the version that was included in the stash and the version that we already had committed in our last commit. And in here now we need to fix this merge problem. And if we do a git status, we see that this file 1 was staged already. Let's say we want to abort merging this stash apply. So what we need to do for aborting this process is we do git restore staged and file1. So if we do a git status again, we see that the file is just modified. So now it's just as if we typed in this message in here, updated upstream, stage changes, but we can restore it again. So if we do a restore file1, it restores it back to the version before we tried the git stash apply. Now let's see how we can actually resolve the merge conflict. So if we try a git stash apply again, of course we get the same conflict. And in this file, so we have the git just printed the old version and the new version, and it's actually up to us what we want to do with it. In some cases you will want the new version, in some cases, or the staged version, the new version that the command is trying to apply. In some cases you will want the old version, in some cases you will want none, and in some cases you will want both. So let's say we want to keep both. We just need to delete that updated upstream line. We delete that line with many equals, and we delete the stage changes line. So now we just save this file in here. And if we do a git status, we can stage the file1 and git add, okay. So if we do a git status again, we can just commit these changes. Let's say applied the second stash. And if we do a git status, we see that everything is clean. Now let's see how we can use stashes in Visual Studio Code. Let's say we add a new line to file1. So if we go to the source control tab and we right click on file1, we will see that we have the option to stash changes. Visual Studio Code also gives us an option to give a commit, some sort of a commit message to our stash. In a terminal, we will have the same option, but we didn't use it. Let's say add the 456 line to file1. And now if we go and we see file1 got reverted to the clean version. And if we go to this ... and source control, there will be a section called stash. So, and then we have apply stash and pop latest stash. And we will just use apply latest stash. And we see that this one adds the 456 line. That was the last concept I wanted to introduce in this first video. We covered a lot of ground, but I wanted to leave you at a point where you can successfully operate your first repository. Next, I would like to discuss the concrete steps that you need to do once you start a new project, and also recap all the concepts that we went through in this video. So let's open back the notes.md file, and I will fill it out before I upload the video, and you will find it linked in the video description below. So what do we do when we start a new project? Well, first of all, we need to be in a directory for our repository. It can be empty, or it can already have some files that we want to track using Git. So navigate to a directory, empty, or it can already have files. Second, we need to initialize the repository. Initialize the repository. We're doing this by running git init and then dot. Next, think if there are some file formats that we always want to ignore in our project. So let's say if we are working on a specific framework like Spring Boot, we can see what is a generic gitignore file for Spring Boot. Search for generic gitignore file specific to our platform. Also, if we have local files that we know they contain API keys or passwords, we want to add them to gitignore. Also, add binary files, file extensions, and also configuration files with secrets to .gitignore. Then we can decide if we want to add the gitignore file to the repository or not. After we created a few files, or maybe they already existed in our directory, we need to track the new files. So add new files to our repository. Add new files to repository. And we do this by using git add. So we can do individual files like git add file 1, or we can use wildcards. Let's say git add file star, or we can use directories, git add, let's say directory, or we can add all the files in our current directory, assuming we defined our gitignore file correctly. So git add and then dot. Git add will mark a bunch of files as staged, and the next thing we need to do is create a commit for these staged files, or you can think about it as introducing a new version in our repository. So let's say create a new commit for the staged files, and you can think of a commit as a version. And if this is the first commit we create in your using Git on your machine, you need to set up your username and email properties inside Git. So we would do git config user.name and let's say first name, last name. First name, last name. And then git config user.email, let's say John Doe at Gmail. John at Doe, and this will set these properties only in the current repository. We can use the global flag to set them on the entire computer. So the same two commands, and we add the -- global flag. Just like that, and if we have this variable set, then we can go ahead and create the new commit. So we can do git commit -m for a short commit message in line, or we can do git commit and without -m, and that will open our configured editor. Next, we can make changes to files we already added to our repository. Make changes to files already tracked. Let's say we modified one file called file1, and the workflow now is we can do git diff and then file1 prints local changes of file1. If we are happy with these changes, then we can stage the file for commit. So we can do git add file1. Let's say stages the file for commit. If we still want to see changes included in a staged file, then we can do git diff -- staged file1. Let's see, shows prints changes of staged file. Then if we want to unstage a file, we can do git restore -- staged file1 unstages file. If we want to discard the local changes and revert the file to the last committed version, we can do git restore file1, say discards local changes. And once we have a bunch of files staged, of course we can run git commit again and creates a new commit. Then we discuss the commands that help us interact with the Git history. So let's say commands for interacting with the Git history. And those are git log, shows the entire history of the project. And we can also narrow it down to a specific file, git log -- file1, or to a directory, git log directory. And also, once we have a commit number, we can do git show, and let's say I'll just put some random numbers that look like a commit number in there. Prints shows a commit with the given commit ID, and also we can see how a file looked at a specific version. Git show, let's say cf2gs, and then colon file1 prints the file at a specific commit version. And then we also looked into git annotate, shows which commit modified. Oh, and this one takes as an argument a file name. Let's say file1, shows which commit modified each line in one file. We then discuss how we can make other file operations like deletions and renames. File deletions and renames or moves. So these commands are, let's say, git rm file1 removes one file, removes file1 from the repository and local directory. Also git mv file1 file2 moves or renames file1 to file2, but the history is lost in the process. Then we have git status that I forgot to mention. It's probably the command we will use the most, and I will add it here in section 4. So git status prints the files that were modified locally and staged files. Okay, and after that we discussed the git restoring the entire project to a previous version, restoring the entire project to a previous version. So the command was git revert, and it can take a single commit. Let's say I'll add some random digits in there, restore a single commit. And then the version where it can restore a range of commits, so restore everything to that commit version, git revert. Let's say this one. So if we want to restore everything to that commit, the range we need to add a caret character to this commit. And this is an alias for the commit that happened before this version. Caret is a git operator, and then we use the ... operator in git, and this will select all the commits starting from the parent of this one, and this range is exclusive to the left up until the latest commit, which is head. So reverts the entire project to the state it had at and this commit version from here. And last, we discussed how we can stash away work in progress changing without creating a commit. So stash away work in progress changes without creating a commit. And let's say we have a file1 and git stash. It saves all the modified files and modified and staged files into a stash. Then we have git stash list, prints all the stashes. Then we have git stash apply, applies the stash at the top of the stack. Then we have git stash drop, removes the stash from the top of the stack without applying. Oh, and we also have git stash show, git stash show -p shows the differences included in the stash from the top. Or we can also use it with a different stash. So we can do git stash show -p stash and at 1, for example, which does the same thing. Git stash drop, and then we have git stash clear, removes all the stashes. And that's pretty much it. That's it for this video. The second episode should pop up on the screen so you can continue watching. If you want to support the channel, you can like the video or subscribe. It makes a big difference. Thanks for watching.